So welcome everyone to the Contractor and Technology Seminar. My name is Russell Ibbotson and I will be the moderator for this seminar. First, I ask that everyone that your microphone is muted. This seminar's format is going to be 2 short presentations and then a panel discussion. If during the presentations you have questions, please use the chat box. And I'll say that if you are watching in full screen, you won't be able to see the chat box, so you could note your questions or write them in the chat box, and we'll be able to get to some of those if we have time at the end. View in the top right corner of where you're seeing the video feed, that's where you can change the view to full screen if you want to get remove the rest of the noise, the visual noise from the screen. Those are the announcements. I'd like to now introduce, and Steve, I meant to practice your family name, so if I get it wrong, I apologize. I'd like to introduce Steve Kadovnik of Artistic Skylights, who is our sponsor for this event. Steve will take 2 minutes to tell us about his company and then introduce our speakers. Without our sponsors, we would not be able to offer this event for free to our attendees. So Steve, over to you.
Hey, thanks, Russell. And you got my name right on. So thanks a lot.
Yes.
Perfect. Artistic Skylight is a premier Canadian skylight manufacturer. We're headquartered in Vaughan, Ontario. We're really a great Canadian business success story, from its humble beginnings in 1980 to having just celebrated our 40th anniversary of service to our customers in 2020. Artistic Skylight designs and builds a whole array of skylight products for daylighting, natural ventilation, and maintenance operations to residential, commercial, institutional, and industrial markets. We also specialize in custom design and fabrication, and we can be coined a boutique manufacturer, kind of unique in our industry. Working with a wide variety of innovative materials and technology, we provide energy efficient products that are rigorously tested to exceed performance requirements of Energy Star program and the North American Fenestration Standard. All of the team members at Artistic Skylight provide strong support to design and engineering community, as well as the construction sector, as we work closely with tradespeople and contractors in delivering successful projects. Offering the benefits of turnkey design, manufacturing, and installation services results in exceptional quality control for the entire project management lifecycle. Our reputation for detail and innovation, whilst being a service-oriented company, is well respected in our industry. I'd now like to play you a brief video that gives you a visual overview of our company.
Artistic Skylight is a family-owned and operated manufacturer of premium commercial, industrial, and residential skylights since 1980. We are known in our industry for our unique niche products and craftsmanship with in-house design, lean manufacturing, and certified experienced installation capabilities. Currently, Artistic Skylight has implemented a new strategic plan to support its growth and an export plan to obtain a more dominant global market. With our headquarters located in the city of Vaughan, we are proud to be part of this booming business community.
So on behalf of all of us at Artistic Skylight, I would like to proudly introduce our 2 distinguished guests and speakers, Yuri Bartzis and Brian Kamet. Yuri's current role as Innovations Manager is within Pomerleau's Canadian Buildings Operations Division. This role unites innovation strategy and implementation for the Halifax, Toronto, Ottawa, and Calgary offices. Yuri works closely with many other innovation managers on Pomerleau's Innovation Operations Committee, which explores new technologies that will have an impact on the construction industry. This committee also pilots research projects aimed at developing new construction methods on Pomerleau worksites. Brian is a senior manager in PCL's Business Technology Group and product manager for Job Sites Insights, JSI. JSI brings IoT AI to the job site, disrupting traditional construction processes and transforming construction technology into an ecosystem of integrated solutions and partnerships, making PCL and the industry a better builder. Gentlemen, you have our attention.
Thank you very much for the introduction. Let me just quickly share my screen. And a confirmation that I'm sharing. Great. So thanks for having me today. And I'm really happy to participate in this panel about technology and innovation in the construction sector. And what I want to show you today is how Pomerleau uses technology on an everyday basis on our construction sites. And innovation is integrated into our company culture. It's used across the board when it comes to better understanding our projects and implementing these technologies, not only in the planning process, logistics planning, but also in how we build, so that we are building more effectively. We're building, we're optimizing our construction schedules and using different technologies at different aspects and different stages in construction, and hoping to share that information and that knowledge. And so today I will jump into some of the ways that we use technology regularly on our construction sites. Obviously, starting with the basic use of our 3D models, which is design coordination. And we take that to the next level at Pomerleau, where we're not only coordinating our design with our design partners and with our subtrades effectively, but we're jumping into that with all stakeholders on the project, whether it's owners or operators and users of the building. And we're able to walk through our construction models very early in the construction stage to ensure that that the information is shared and the knowledge is shared, and that's the key, the important part there. We take that knowledge, we implement it into our planning process, and you can see on the screen there is very much a lean planning process. We do lean planning on our job sites. We also take that to the next level using digital technology, and we do 4D technology, 4D construction on our construction sites. The 4D construction again is is staple for the way we build. It's to better, not just for us to better understand how we're going to tackle these construction projects, but to share the knowledge and the plan essentially of how we want to tackle construction. It's that sharing of knowledge is what is really helping us grow, helping our project teams grow, but also helping the industry grow, because we're sharing this information with our trade partners and owners and all stakeholders on the project. So you can see we even take it to the level where we have weather effects to our construction sites, and that helps better understand at what stages our construction is happening, and to really look at these 4D models not just as an animation of construction, but essentially a true breakdown of our construction schedules month by month, even almost week by week, so you can see the entire building being built. We also use VR technology regularly in our processes. We've developed in-house certain advancements in the technology so that we can show our stakeholders optimal paths for pedestrians around our construction sites. So not just to visualize the construction and what we're going to be building, but to visualize the space around our construction sites. And we're able to take that VR technology right to the site team and walk through the construction effectively using new developments that we've developed in-house for location, but even for measurements and coordination applications, where we can measure from these model spaces in the VR space as well. The next step for coordination is bringing that to our the end user of these buildings. So we use the VR as an interaction with the end user so that they can interact with the building that we're going to be building for them, whether it's moving chairs or opening desks. They get a better understanding of how the space is going to function, and all of this is to optimize the entire construction process in terms of RFIs, changes in design, and that as you'll see a little bit later in the presentation, is going to be very important for some of the advanced technologies that we're starting to use. So when it comes to surveying and layout, this is now taking the the technology from planning and digital to what's happening on our construction sites. So our innovation team, as I mentioned, is involved in every stage of the process. We do 3D scans of our construction sites to gather information. We do the data acquisition as construction is being is progressing, and we work with our subtrades. So whether they're using this technology or it's us, we foster the sharing and collaboration of information to make sure that there's that effective transfer of information throughout the entire construction process. This is another way where we're catching information from our sites using 360 cameras, and these cameras are used in comparison to our 3D model, which is essentially the finished product, to better understand where we are and where we need to get to. Drone technology is another way that we're capturing information from our construction sites as they're happening. Sorry, I think there's some issues with the video, but we take the output from our drones, and we do analysis on that data that is coming in from all of these different aspects, whether it's a drone or camera or scanning. So the information that we gather is usually quite accurate and very usable in terms of data, and you'll see how this data can be effectively optimize our entire construction process and then shared with the end user, which is up next with the facilities management section of our data. So all the information that we gather from design and construction, we're transferring that to the end user, to the owners of these facilities, and we're making sure that during the design, the end user understands what we're going to be building. It confirms that what we're going to build is essentially what they need in the end process, and how they're and exactly how they're going to use the different systems at the very end of the construction site. So we with the VR sessions, we go in there with our operations, with the operations teams of the buildings, and make sure that the final product is optimized to their usage as well. And here's another example of how we take information from construction and even the commissioning process. So we take the spec data from each of our equipments, input it to our 3D models, make those links between warranty information, spec information, and any other data that is collected throughout that commissioning process, and transfer that information digitally with our 3D models to the end user. And now I want to show some of the advanced technologies that we're able to do now that we have created a solid foundation of all of these different technologies that I ran through. So we take that foundation, and right now we're able to do research and development on new aspects, new technologies, new innovations in our industry, be it prefabrication or using sensor technology and the Internet of Things, that's the IoT there, to really better understand our construction sites, acquire the data that that is being generated throughout construction, be able to analyze that data through artificial intelligence, share that data with manufacturing, whether it's offsite manufacturing or even with robotics on our construction site, and push that to the next level of how we're going to build in the future. So we're doing effective research and development in offsite construction, where we're better understanding how to plan construction so that it can be built in a factory. So all of that analyzing of design, quality checking our design is used to finalize the design at a point where we can fabricate in a factory and deliver to site for installation. And on the installation part of it, we're using the surveying and quality checks that we've been using on all our construction sites to optimize the execution of these prefabricated modules, to make sure that the quality and accuracy is exactly where we need it to be to build offsite. We're using geographic information. So all the data that we are collecting from different construction sites, we're able to visualize that data geographically. So not just looking at the one site level, but taking that to that next level, taking a step back and looking at large maps, different construction sites, historical data that we've acquired from previous construction, and linking that to maybe a new construction in the same area, the same region. Using GIS, which is the Geographical Information System mapping, to optimize the use of data. Robotics is something that that is quite new to the construction industry, and we're working with innovation partners. Boston Dynamics has shared their mini robot that we're currently piloting on our construction site to optimize certain processes throughout the construction, to see how robotics can mix with our on-site teams. And lastly, we do have development in the IoT and tags and sensor technology, very relevant these days when it comes to contact tracing and the situations we find ourselves in. So even with new problems, we're finding new solutions to how we build on construction sites, and we take that to the site teams to test and pilot. So thank you. That's the end of my quick analysis of the Pomerleau's innovation strategy, of what we're doing and where we're going, and trying to get us to a way of how we're going to build in the future. And it's we really don't know what it's going to look like, but it is exciting. So thanks. I'll pass it to Brian.
Thank you, Yuri. But definitely some interesting material there. My presentation is going to take a bit of a different focus. I'm going to focus on one of the technologies that Yuri described at the end of his slides concerning IoT. And PCL has released to the marketplace and is using internally a product that we call Job Site Insights. So thank you for the opportunity to speak today. I appreciate that Russell is a volunteer and his team is a volunteer. So as we make my way through this virtual meeting, I'm not familiar with Zoom, so bear with me if I make any errors or fail to project something correctly. So I'm the senior manager in our business technology group, and I'm also the product manager for Job Site Insights. So I'm going to spend 10 or 15 minutes to take you through the product and describe some of the innovative work we believe we're doing in the area of IoT, or the Internet of Things, and a particular application known as Job Site Insights. And my screen is having some difficulty advancing, bear with me. So why did we dive into Job Site Insights? We recognized, as the industry does, that construction is very risky and fraught with dangers on the job site and issues that can arise unexpectedly. And there's countless research, if you fire up Google, around, construction rework being costly, schedule being at risk. McKinsey, in a particular publication I like, Imagining Construction's Digital Future, speaks about the lack of digitization in the industry and the impact that's having on schedule and budget. Construction is known to be a laggard when it comes to productivity versus other economic sectors, and the research has supported that. And of particular interest, JSI is water damage. Water damage on construction sites are the leading cause of builders' risk claims. And here at PCL, and I'm sure at Pomerleau and other organizations, the evidence bears it out in the risk management data and the claims data. So we really wanted to build an application that addressed all of the issues on a job site, and we saw IoT as the vehicle contributing as a tool set to do that. So really, Job Site Insights, its innovation and its value to the job site is directly that. We have to show results with these products in terms of advancing schedule, reducing costs, improving our build quality. If you have damage on a job site from water damage, for example, that impairs your quality, that creates rework, which is costly. And really, at the end of the day, if we can improve our profitability and reduce our costs and make our customers and clients happier with a better product, we've succeeded. So JSI today is deployed across approximately 100+ projects in North America, Australia, and Europe. So we have customers in those areas. And of course, most PCL job sites, depending on their nature, are utilizing JSI to protect against these adverse events. So really, how does this work? So we deploy wireless IoT sensors on the job site that are ingested in the Job Site Insights platform, a cloud-based application that runs actually on Microsoft Azure technology. That is its technology foundation. And that data is analyzed as it's incoming and looking for anomalies and events or conditions on a job site, such as freezing temperatures, water leaks, wind conditions that are impacting safety or could impact safety. And I've got a slide where I'll describe some of the sensing capabilities of the platform. And really, we enable an immediate job site response and corrective action by job site personnel. So as you'll see shortly, job site personnel are connected to the platform, their mobile devices, receive alerts and notifications. And in doing so, we are able to improve schedule and avoid these risks and dangers on the job site and accrue the benefits that you see on the right-hand side of the screen. And I'll describe a case study where I'll provide some quantitative evidence as to how that's come about. But at the end of the day, and I think Yuri talked about this technology and others are making the industry and PCL better builders. And what we, smarter construction. I come back to McKinsey, who I believe in their study ranked construction out of 22 industries, second from the bottom in digital maturity, slightly ahead of, I think, hunting and gathering, if I recall correctly. So it's interesting that we're a laggard, and I think innovative solutions such as Yuri's describing and Job Site Insights are really are moving the needle in terms of the industry's digitalization and ability to use technology more effectively. So here's a screenshot of the JSI portal. So as I said, those sensors are communicating in real time and communicating information wirelessly to a gateway, which is transmitting data to the internet and onto JSI. So we deploy this on job sites, and we have a visual representation of, in this case, a floor plan of a building under construction. And you can see the various sensors arrayed and placed in their location. And of course, job sites are mobile. Construction personnel do not carry laptops around. They operate with that device on the right there, the phone. And really, that's the most significant part, in my opinion, of JSI, the mobility factor, is that we're giving the tools to the job site where the phone is a popular item to be used on job sites, as is an iPad on occasion, but the phone is the #1 vehicle for communication, data, and interaction with these things. So we have a real-time view into the conditions of a job site, depending on the sensors that are arrayed. Here we see flood sensors, water damage again being a significant cause of builders' risk claims. We have temperature sensors, sound sensors, concrete sensors for concrete maturity, and I'll describe those shortly in one of the particular slides that discusses what we can sense and how we do that. Similarly, mobile, as I said, we saw previously a mobile device. And really, the mobile device is simply the tool of choice on job sites these days, such as an iPhone. So interestingly enough, and why we built this particular application is the other things job sites demand is simplicity in technology, ease of use. And when we install a sensor, which is shown on the bottom, on the left, the bottom of that screen with the QR code, the sensor is installed or affixed on a wall, for example, if it's a temperature sensor, the QR code is scanned and the data, including the location of that device, is automatically input into the system via the scan. So the type of device and where it's located is automated. We don't want people to be having to type that in manually. Similarly, they can set up alerts. They can set up teams. You want to notify a construction team of an event such as a water leak in the mechanical room, and those alerts are sent out, and they can do that on their phone. They can also do that in the main application. And as you see on the right-hand side of this slide, the most of the functionality found in the web portal is found on the mobile device. So, where have we used this, and what are some use cases of IoT technologies on the job site and this, what I call an early warning system of adverse events? The most popular, arguably the most popular sensing capabilities are for freezing temperatures. It's gotten cold here in Edmonton, as we all know, and elsewhere in the country. So freezing temperatures lead to water damage typically. And the case studies illustrate here the results we've achieved on job sites. At a large hospital in Ontario, freezing temperatures prevented water damage or potential water damage from freezing pipes. in the hospital's finished auditorium. In a 35-story tower in Toronto, this is a unique, the first use of water detection in the system. While we were there, a water leak that you couldn't see was detected, and the water supply valve was automatically shut off in response to that water detection. Had we not detected that, the fire suppression pump room equipment, ironically, which is susceptible to water damage, and to the tune of $300,000, we prevented that damage. And here in Edmonton, on a large tower project, the use of concrete sensors reduced the formwork and form stripping schedule and concrete pouring to the amount of 1,100 hours, which is roughly 45 days in schedule. So some significant benefits from that. And I've got some details on that particular case study, the ICE district here in Edmonton, the two towers that PCL built on the left and the right there. It was actually the first job site deployment of JSI a couple of years ago, and a 10x return on our $46,000 investment in temperature and humidity sensors, which were expressly used to monitor the temperature and humidity conditions during the finished construction work. So there was a lot of high-end materials, expensive mill work in this structure, and the $175,000 that were budgeted for millwork damage and included in the estimate were never realized. So we had a significant savings there. And because of temperature sensing, we were not running heaters continuously in the cold weather, which is typically the case on a job site. And we realized significant energy and carbon fuel savings by not having to do so. And then lastly, as I mentioned, the concrete sensing. Concrete sensors, which are embedded in the concrete to measure its strength, temperature, and maturity, enabled formwork stripping to proceed more quicker than automate or third-party testing. So typically on a job site, concrete test cylinders are taken, they're taken to the lab, they're analyzed in the lab for compression strength and other factors. And we've done that now on the job site by monitoring that strength and maturity in real time. So we saved not only schedule, but we had quality improvements as well. Third-party testing can be fraught with errors, as you know, there's improper handling of the cylinders on the job site, inaccurate or in cylinder breaks performed at the wrong time. And then lastly, the safety implications. There are safety liabilities when third parties attend the job site. They're unfamiliar with the site, they're traversing the job site. So we reduce the number of third parties present on a job site and potentially remove that safety risk and the safety liability. So when we saw the results from this project, we realized that we were building a product that benefited PCL, but one we are now commercializing and offering to the marketplace because of the value proposition. IoT data is pretty simple. It's time series data. That's really what it is. And you know, we have descriptive analytics. We can show the data that's occurred from the IoT sensors, such as temperature history. That has actually proved valuable. Surprisingly, in Ontario, we had a project where a construction worker lodged a complaint with the Ministry of Labor concerning temperature on a job site. The inspector showed up at the job site. The superintendent displayed the analytical results, the historical reports of the temperature, which were within the acceptable parameters, and the complaint was dismissed. So that evidence-based approach to managing a job site is certainly valuable. But I think more importantly, and what we're doing with analytics, is the entire platform is built on an API framework, an application programming interface, an IT term for connectivity and integration, which really exposes the application to other data sources in the organization, you know, your risk data, your safety data, all of the data illustrated here. And now you get into the predictive capabilities and the prescriptive capabilities. For example, we can now predict with other data sources the probability of safety incidents. And we're seeing that in the marketplace. There are organizations offering these solutions, and we've decided to do a lot of that on our own, as I'll show you shortly. But the fundamental point here is that we collect the data, we expose it through APIs to other operational or corporate or even third-party data sources. Weather data is a great example. We can bring in third-party weather data through APIs and present that on a single pane of glass, which I'll talk about shortly. But really, we're really focusing on the analytical aspects and the value of all the data that construction companies hold. I know Yuri can speak to this. We have a lot of data. It's often in silos and we don't do much with it. So we're really looking for ways to expose that. Of particular interest is the last one there on the analytical side, the cognitive capabilities. And this is where my team is really involved heavily in advancing another product in the JSI ecosystem, job site vision, the use of computer vision and machine learning. So in the first example here, that's actually a vehicle in our parking lot. I couldn't get out to a job site with COVID, obviously, where we're able to detect and determine what that piece of equipment is, in this case, a truck, and it's leaving the parking lot, or in this case, a job site. So we can identify the visual characteristics, the plate number, all through computer vision, when the truck arrives, when the truck leaves. And that's important on a job site, especially when you have congested job sites or for security purposes and gate monitoring. But more importantly, we're extending JSI, which is an anomaly detection system, visually. So we're applying vision in the quality and safety domains. And of particular interest right now and what we're working on is trench or excavation inspection. Excavations are dangerous, and if they're not constructed and secured properly, they can cause injury or even, unfortunately, death. And at PCL, we call that a life-saving absolute, trench safety. And we're now using visual analytics to examine trenches and visually detect the anomalies. Are the barricades there? Is the angle of inclination on the ramp leading into the trench sufficient or within the design parameters? Similarly on quality, I mean, certainly we've had cases where, for example, very simplistically, the wrong size rebar was used before the pour executed, and now you have to tear it up because you've used the incorrect material in the concrete work. And we wanted to detect that visually with job site vision and machine learning. So that's what that product does within the ecosystem. IoT, very briefly, I've bastardized the definition of IoT, but as really what it is the use of connected devices that can speak to the internet. And the world has billions of these, your Fitbits, your baby monitors. I've got a Fitbit and it's telling me I should get up and exercise more. Well, JSI and IoT on a job site is really about, awareness of what's going on and delivering, the key word here is actionable information to job site personnel about events and conditions that if you don't mitigate them, you're going to have costly downstream effects. And really that's the value proposition behind JSI and the use of IoT on a job site. So we're really happy with the results we've seen and where IoT is taking the platform and what it's offering the industry. This eye chart, I don't expect anybody to read it, but this is the sensing capabilities currently available in the platform. We're, and we're really focused on HSE, the health, safety, and environment domains, the risk mitigation and build quality areas, operational efficiency or construction excellence. Operational excellence on the job site is important. Construction is a low margin industry. And if we can save costs and improve our fees, our profitability increases, as does the industries. And then, of course, sustainability is important. It's important to build green and the sensing capabilities, atmospheric conditions. Are we producing too much dust on a job site and the surrounding communities affected? These are all concerns of JSI. And I can certainly share this if anybody's interested in what it's available in the platform, but really those are the domains we're focusing on. The other thing too is we are sensor agnostic. That is, we use LoRa sensors. There's another buzzword, LoRa, long range. That's a communication protocol for IoT sensors that is arguably becoming quickly the industry standard. So if there is a LoRa sensor that our customers require, we can incorporate it into the JSI platform. And that's significant because many of these technology vendors in the IoT space have proprietary or closed systems. And we believe in an ecosystem. The technologies are growing too fast, too rapidly, and too valuable across a wide domain to lock into a particular vendor. So we always look for LoRa-enabled sensors, and we respond to our customers' demands in terms of what sensing capabilities are required. So lastly, I want to speak briefly about our ecosystem. We've built some complementary products, and I'm going to call attention to the ones in red boxes here. Job site vision, I already spoke about, the use of computer vision. Job site resourcing is integrated to the IoT platform as well. That's about logistical management on the job site. The conveyance and movement of materials and equipment. Job sites are confusing, laydown yards can be large, and often there's competition for lifting devices, cranes. We've built a system that uses IoT technology as well as an application to better manage that. Job site access, I think, is very relevant. we have built a system, especially in today's era of pandemics. We use facial recognition to admit job site personnel to the job site. We can also have secondary temperature screening and divert employees according to corporate or public health policies that might be in place. What's really interesting about job site access is we now have the ability, I talked earlier about integration, to tie that employee's records, their health and safety records, their training records. And you now have the ability through JSI to alert the supervisory staff to the fact that, hey, Mr. Worker X or Mrs. Worker Y, their fall protection training is out of date and they should not yet proceed to the job site until their training is up to snuff. So we really have the ability to bring in other data sources in the JSI platform and alert job site personnel not only to existing conditions, but potential hazards such as an improperly trained employee. So we're really extending this across breadth, and we believe in third-party ecosystem participation. Eddy Water Solutions, a Toronto-based company, provides our water sensors and valve shutoff capabilities. And again, because they operate with the LoRa protocols, we're able to bring them into what I call, lastly, this single pane of glass. So we're now building the applications to be integrated on that single pane of glass and give it more of an apps feel, if you will, that we're familiar with as consumers. I want that app on my phone. I don't want to have a lot of hassle to get the app, and I simply click and I'm able to bring it into the ecosystem. So that really describes very quickly job site insights and PCL's foray and use of IoT on the job site. So that's all I've got in terms of our technology presentation for today, and I'm hoping we have some questions from our audience. Back to you, I presume, Russell.
Yes. Okay, so we did have some questions, and we had some questions as well, Brian and Yuri, that we had sorted out. We've got about 10 minutes. How would you guys prefer to do this? And the questions are in the chat. They're pretty straightforward. Or we can try a couple of the ones we predetermined, and then grab a couple from the chat. What would you guys like to do?
I'm open. We could do the predetermined. I'm not, again, my Zoom inexpertise. I don't see the chat questions, so I'll rely on you, Russell, to read the questions if you would.
Okay. So let's try. Maybe we'll bounce back and forth a little bit then. So I have a good question. Where did it go? Bear with me 1 second. Brian, for Job Site Insight, is this available for other companies or institutions, or is it proprietary to PCL?
Yeah, great question. And I think I alluded to that in my presentation. We are offering this, and we have sold it to other general contractors. So it is in the marketplace. It's early days, certainly. We've acquired a few customers, and I don't mean to shamelessly flog it, but if there is interest in using this software on your own job sites, I should also point out it's used in other industries. We have customers. I'll give you a very simple example. A food processing company in Toronto acquired Job Site Insights to monitor the conditions in its food processing facility, particularly temperature. It's used in the pipeline industry for pipeline integrity and pipeline monitoring, as well as it's been deployed in the mining industry in Ontario to, in particular, monitor the electrical cables used on mining equipment. Damaging those brings the mining operation to a halt, or potentially brings it to a halt. And they want to be able to detect where cable breaks occur in electrical cable that supply power to the operations and equipment on the job site. But yes, short answer, it is available, and I'd be happy to share my contact information and take that further for those that might be interested.
Okay, excellent. Thank you, Brian. Yuri, I'm going to jump down because I know you added Spot into your presentation after we spoke. Can you tell us a little bit more about what the Boston Dynamics robot is doing on your job sites?
Yeah, for sure. I'd love to jump into a little bit more detail. So Spot obviously is an autonomous robot, and I think we've all seen the Boston Dynamics videos, media on LinkedIn. They launched a great video recently of all their different robots dancing, which is great, and Spot does dance. But bring that to the construction industry, because Spot is used in multiple industries, but we've brought Spot into the construction industry. Parmelo is piloting exactly what an autonomous robot can do on a construction site. So we input data into Spot that outlines exactly what our construction site looks like in terms of floor plan. We can automate its path of where it will travel and where it will stop in certain instances. And the travel path is very, it's generic. The robot responds to objects in the way or piles of dirt that it needs to climb over in order to maintain its original automated path. And we link different technologies with Spot. So we mount a 360-degree camera onto the back of Spot, so that when it stops into one of our locations, into a room, it can take a 360-degree photo. Again, a lot of that data acquisition that we're looking for to do analytics, whether it's performance analytics on progress on our construction site, or even just to capture quality of installation. Are we installing according to the original plan and our 3D models? So that's a 360-degree photo, and using photogrammetry, we can take that photo and create a mesh, which is a digital representation of multiple photos, and we overlay that with our 3D model, and that's how we check the quality of our construction. And now we've started playing with a LiDAR scanner. So instead of just the photo and photogrammetry, which is not super accurate, I think it's accurate up to 3 inches, we mount now a LiDAR scanner on the back of Spot, and the same situation, acquiring data from our construction sites, and the LiDAR scanner is now accurate to a few millimeters, which is amazing for an automatic robot to walk our construction site and gather that extremely accurate information autonomously throughout the construction site.
Oh, that's fantastic. Thank you, Yuri. That's it's impressive. Brian, I have a very CSC type question from you from our audience. What is the approximate? It's a two-part question. I'll let you know. What is the approximate cost to implement JSI on a project? And is this something that could be written into the specifications to force the contractor to use it?
Yeah, that's a great question, and I always hate talking about pricing. So what I will say is that the cost of JSI is really dependent on two factors. Number one, the nature of the job site and what sensing is required. So typically our customers will purchase the sensors and the hardware, if you will, and that can vary widely. And then lastly, the software cost. JSI is a software as a service delivery model and subscription-based model. And we work on that individually with each client, depending on the nature of their sites. Are they looking for an enterprise application, perhaps, to cover all of their job sites? So I don't want to nail myself down with a particular price. And we look at the situation that's required on a given job site, for example, or a series of job sites. Obviously, on a small special projects that, a mall renovation or a renovation of a small facility versus that of constructing a large hospital, such as we're doing in Calgary with the Calgary Cancer Center, the costs can vary. But really, it's a function of the subscription cost and the sensors required and what the customer or the general contractor wishes to measure and monitor.
Okay, so you could build a package to accommodate a project.
Precisely. It's and did you have a two-part question? Sorry, I think I missed the second part of that.
Right. The second part is, could it be specified to force the contractor? So this is from the design consulting side. Can you specify that this system or equivalent would be required in the project?
I suppose that's a possibility. I mean, I look at the water sensing capabilities. We're getting a lot of attraction from the insurance industry to that very question, because if insurance agencies, or pardon me, insurance underwriters and organizations, the big industry players in insurance, if they can minimize the claims, it's a benefit to them, obviously, on paying out damages, and also on the other side of the fence, the general contractor reducing premiums or builders risk claims certainly has an overall benefit economically to the job site and to all the parties involved. So as to demanding it or specifying it, I think that is more of an operational or business decision. I haven't seen that yet, but it's certainly of interest when you consider as I said, as an early warning system to these potential faults or conditions on a job site that create cost. I equate it to putting smoke detectors in your home, and that's not a great analogy, but it's one that protects you from, there's a sensory protection there against damage to life and limb. In this case, on a job site, it's a broad array of damages and events that can occur against safety, productivity, and schedule.
Yeah,
Right,
and
and I think you captured. Sorry, go ahead, Yuri.
exactly, and I'm going to jump right in there and say that this is going to be a standard across all construction sites in the future for sure. So it's not only JSI, but as you saw, Parmelo's looking and very interested in this technology, and there are sensors out there in this industry and other industries already that are being utilized for acquiring data.
That's excellent. So I'm going to combine a couple of questions that we had worked on. Now, you're both showing some real maturity in the development of these technologies, and it's clear that you're a good distance down the road in adapting them and developing them. Can you tell me maybe one of the challenges that you've had bringing this technology or the technologies that you're pursuing to the job site, and how you've dealt with that? And maybe Yuri, if you wanted to go first on that one. Oh, you're still muted, Yuri.
Of course. Sorry about that. But some of the challenges that we've had ourselves is when we're collecting so much data from our construction sites, whether it's little alarm bells might go off from some of our on-site workers. Exactly what data are we collecting? And we're collecting a large amount of data, but there is a lot of data that we're not collecting and even not allowed to collect when you look at some of the privacy acts and protection of personal information that's out there. And essentially that's it. It's a little bit of an education process to our members on the construction sites that we're not allowed to collect some information. There's some information that we are allowed to collect that we're not going to use. We're not monitoring how long people are going for breaks or how long they're effectively working. We want to make sure that it's in the realm of safety and construction site optimization. So it's not really an HR reason why we're collecting data. So that is one of the real big questions that come up when we're trying to implement this technology and collect more information from our construction sites.
Yeah, I could see people being nervous about that. So a little bit of education goes a long way there. How about you, Brian?
I think from a technology perspective, I mentioned earlier, McKinsey ranks construction as a digital laggard. And I think the challenge we have in PCL and perhaps other organizations that are general contractors is adoption and willingness to use it. I mean, there are processes in construction that are 80 years old and are unchanged. There's nothing wrong with that because they're typically proven and well-founded. But I think as we drive adoption and the use of technology, you have to show results. You have to prove value to people on the job site. It has to be simple to use. It has to be easy to use. And you want to have them use it because they want to use it, not because IT is demanding that you use a particular technology. And I think that speaks to the second point. It's not just JSI, simplicity. You look at the technologies Yuri was showing today. I mean, Spot is a complex technology, but arguably it's rather simple to use. The dog runs around, the dog's doing the work. And that I think the simplicity and the adoption is driven by simplicity and demonstrating value. And also in our own organization, our director of integrated construction services, which is really the bridge, if you will, between IT and the field, that's an old adage, what gets measured gets managed. And he's actually measuring adoption and seeing what are the causal factors for technology not to be adopted, and engaging directly with field personnel to say, hey, we've got this technology, you should be using it, here's the value. And then we uncover the reasons why they're not using it. And often it's awareness. Yuri's point about education, it astounds me in PCL how, despite being a large organization, that some people are not aware of some of the technologies available to them. And it's our job as technologists and innovators to make that awareness happen. And I think that's a challenge, especially in a diverse organization. And I think it's pervasive in the industry. There's big reasons why we're digital laggards, but I think we're getting very good at improving that.
Well, I certainly think that this panel discussion and your presentations are, going against what McKinsey's stating in their report, and hopefully with you guys leading the way and a few other the companies coming along for the ride, we'll see construction go up that list. So thank you very much, Brian. Thank you very much, Yuri, and for a great discussion. I think there's a lot more happening here than I knew. And I'm very happy to say that construction is going to distance themselves from the hunting and fishing sector in the technology laggards. Thanks once again to Steve with Artistic Skylights. We are going to go into break. I know there's some people working in the background trying to sort out a few things. So hopefully this will get smoother as we go into the next session. If you go to the sessions, break 2 will have a couple of announcements. We have a few minutes, so we have 15 minutes before the next session start. So I do ask that you take a few minutes to visit our exhibitors. We have 80 exhibitors there, and they're the reason why we were able to offer this program today for free. They paid to participate, and we thank them for that, but we also ask everybody to take a few minutes and meet with them. The next sessions do start at 2:30, so you have a few minutes now. And I'll leave this call open for 4 more minutes before closing it down if anything else comes up. So thank you very much, everyone.